Hi everyone. Have you ever looked at a map and thought, hey, those continents kind of look like they could fit together? Well, you are not alone. Today we are going to talk about the idea called a continental drift theory. It's all about how Earth's big land masses move around. In 1596, this idea first hinted by Abraham Ortelius, but the person who really made this idea famous was a German scientist Albert Wagner, who was actually a meteorologist. That was around 1912, but the idea published in 1914, and it changed how we think about our planet. So, what did Wagner say? He believed that a very long time ago, all the land on Earth was connected in a one giant supercontinent named Pangaea, and this huge land was surrounded by a big supergiant ocean named Panthalacia. Later, this land Pangaea split by a Tethys Sea into two big parts, Laurasia in the north and Gondwana land in the south. Then, about 200 million years ago, this big landmass started to break apart. Imagine a huge puzzle slowly breaking into pieces and drifting away from each other. That's what happened to our continents. Now the big question arises, how did these giant land masses move? What was the forces behind it? Wagner thought that there was two main forces. The first one is the equatorward, means pull toward the equator. He believed that this happened because of the Earth's gravity, a pole fling force, and a buoyancy, means like how she floats. Think of it like this. Earth isn't a perfect sphere. It bulges at the equator because of the centrifugal force from the rotation. As we move from the poles toward the equator, the centrifugal force increases, essentially pushing away the land masses away from the poles. The second drift is a westward drift, which caused due to tidal currents generated by a gravitational pull from a sun and moon. He thought that because Earth spins from west to east, these tides would push the continents from east to west. A fascinating concept, right? Even though his idea about the forces were not quite right, Wagner had some really good evidences that the continent did move. He looked at things like how the continent seems to fit together, how the poles seems to have moved, where fossils were found, rocks of the same age across the ocean, biological evidences, and like that. Now, let's look at how the continents fit. If you look at the map, the coastline of South America and Africa really look like they could snap together. It's amazing. The bulge of Brazil even seems to fit perfectly into the Gulf of Guinea in Africa. And it's not just them. Africa, Madagascar, India's east coast also line up well. Even Greenland seems to fit with the parts of Canada. But this fit isn't just a coincidence, it's supported by other evidences, like position of poles constantly shifting. There are also climate indicators. There are also evidence of past climate found in a location which is very inconsistent because of their current latitudes. For instance, coal deposits found in a temperate and polar region, but coal formed in a tropical regions. Another big piece of evidence came from fossils. Imagine finding the exact same type of ancient plants and animals on a continent that are now separated by huge oceans. For example, a small crocodile-like reptile called a Mesosaurus, which lived in a fresh water, is only found in southern Africa and eastern South America. How could it be in both places if they were not connected? It suggested that they were once a single land. Now, the next evidence he looked at is the rocks of the same age across the ocean. He found that a belt of a very old rock, about 2000 million years old, on the coast of Brazil matches rocks found in Western Africa. This is like a geological fingerprint that shows they used to be neighbors. If rocks matches, it means a living thing also do that, right? Even some animals, like lemmings, seems to migrate west, almost as if they remembered a time when there was a land there instead of an ocean. Even with all these evidences, Wagner's theory faced a lot of criticism. One major point was that coastlines are temporarily and constantly changing. Others argued that you could find many unrelated landforms that might seem to be fit together. Some critics also pointed out that Wagner's theory placed India too far south, which distorted its relationship with the Mediterranean and the Alps. And surprisingly, the mountain didn't always show the expected geological affinity. But the greatest criticism, the most significant hurdle for Wegener's theory, revolved around those very forces he proposed for the drift. Experts argue that if the gravitational pull of the moon or sun were strong enough to break apart the land masses, it would have been powerful enough to stop Earth's rotation entirely. Furthermore, to cause such a drift, the rotational speed required would be so extreme that it would literally fling the atmosphere and everything else in the outer space, far beyond Earth's gravitational pull. Clearly, these forces just didn't add up. Other critics said that maybe the poles shifted, not necessarily the continents. Also, similar plants and rocks can be found in different parts of the world, not just where continents were supposed to be joined. And Wegener couldn't explain why the drifting only started in the Mesozoic era and not before. Plus, his theory didn't really think about the oceans themselves. So, where does that leave us? Was Wegener's idea completely wrong? Not at all. Despite its initial rejection due to the problematic forces, he proposed the core idea that continents do move, remain a powerful and undeniable truth. It became the driving force, the essential foundation for later, more complete hypotheses such as the groundbreaking theories of plate tectonics and sea floor spreading. Wegener truly set the stage for a modern understanding of how our Earth truly works. Thank you for staying till the end. I'm going to come back with a new lecture. So stay tuned and stay curious.